All right. So, chapter 14, if there was one chapter that you could remember from this class, just one, I would want you to remember this one because object-oriented programming is the bread and butter of coding. It's how can I put it? If you don't know object-oriented programming, you're not going to get anywhere in coding. So, this is a very important chapter. I want you to focus as much as you can and try to remember everything that I'm going to be talking about. And I'm going to split this chapter in half. So today we're going to cover up to 14.3. And then on Thursday, we're going to cover the other half. Just because I want to put a big emphasis on this chapter and I want you to understand like how important it is to pay attention to this stuff and know all of these all of this information. Anyway, so before we start talking about object-oriented, let me introduce you to procedural programming. And procedural programming is basically what we've been doing this whole class, and it's just defining variables and defining methods. It's all it is, all that we've been doing, putting them all in one program in your main class and just going with it. So basically, very early method of coding. This is how it all started after the punch cards and after the zeros and ones, the flips of zeros and ones. Procedural programming was this thing. And procedure is what we call a module right now. Sometimes you will also see functional programming and same thing, functions, remember functions, modules, same idea. However, as our programs get larger and more complex and they take thousands and thousands of lines of code, this method presents a problem for us because procedural programming will give you a lot of errors the more code you have to work with. So this is where object-oriented programming came in. And in object-oriented programming, the first word is what you have to focus on, objects. So what we do in object-oriented programming is we are creating objects. And those objects, they will have two things. They will contain two things, data, such as variables and arrays, and procedures, such as methods. In object-oriented programming, we call our modules methods. So from now on, I will refer to any modules as methods. So all you have to know about objects is that, let's imagine you're playing a game. Have you ever played a game where you need to create your own character? So in those games, you can pick characters, eye color, hair color, all of these specifications for your character. Think of those as variables. So you creating variables for your objects, the way you would create your character's look. And then, for example, sometimes in games, you can pick your character type, right? So for example, some characters will be good with a bow, some characters will be good in strength, some characters will be good in stealth. And think of those as picking the methods for your objects. So variables as characteristics for your object, and methods such as actions for your object. Now, two things that we need to know, two methods. First one is encapsulations. And encapsulation just means that we are combining our data and our code into a single object. So what that means is we're taking our variables and we're taking our methods and we're combining them and assigning them all just to one single object. So not too many, not too multiple, because the way we used and the way we wrote programs before, remember when we wrote our methods, we could use our methods anywhere, right? We can use them anywhere in our program. Any variables, we could attach any variables to those methods. But with object-oriented programming, all of those methods and all of those variables will be assigned only to one single object. And here's another thing that comes in, data hiding, that comes in with encapsulation. Data hiding just refers to all of those methods and variables that we assign to that object. No other objects can see them or use them, okay, or change them. So That's all that means. And another benefit for object-oriented programming, as I told you before with modules, remember that I told you that modules are really good for reusing them in your future programs. For example, if you wrote one module and it does some function for you, you can reuse that module later in a different program. Same thing works with object-oriented programming. If you have created an object that does something for you, you can just reuse that object later on in a different program because you already know how to write it, you already have it. You can just copy and paste it into your new program, basically. And with object-oriented programming, as you can see here, an example, if you have an object that's going to render a 3D image for you, you can just keep reusing it in different programs as you go on and as you write more and more code. Now, another very important concept, a class. So a class, think of it as a blueprint for your object. For example, let's think that, let's pretend that our class is a blueprint for a house, right? Then our object would be the actual house. So a class can, it's like a detailed description. So let's think of a class as a blueprint for a 2-story house. Can you create an object from the blueprint that's going to be a 1-story house? No, because our blueprint is for a 2-story house. So the only thing that you will be able to do is to create a 2-story house. However, you will be able to specify different specifications for that house. For example, if we have 2 objects, we have to create 2 objects, 2-story houses. One house will have a blue roof and the other house will have a red roof. That is perfectly fine. We can do that with objects. All right, so our class is just a very detailed description to build your object, but it allows you a little bit room for specifications. And I'll show you an example of that. So, and speaking in coding terms, an object is going to be called an instance of a class. So something that belongs to that class, something that came out of that class. This is what it would look like if you wanted to define a class. This is pseudocode again, but in your languages it will look differently in different programming languages. But this is just a I'm blanking. Pseudocode for defining a class. So you would have some sort of name, some sort of code name for class. For example, in Java, it's just class, but you would have to put public or private, but it would just be class and then the name of your class. And then inside of that class, you would define all of your variables, field declarations. When you see field declaration, it's just like variables that you assign to that class. So any of your variables and any of your methods are going to be inside of that class, and then some sort of ending for that class. Now, the naming rules for your class are pretty much the same as naming your variables. However, in some languages, your class has to start with a capital letter, and variables have to start with a lowercase letter. For example, in Java. Now, access specifiers. This is where the access specifiers come in. Python does not use those. However, Java will use this. You will use these in our next class. We will have to use private and public. And what it means, private is pretty simple. Private just means that everything that's inside of your class cannot be accessed by anyone who's outside of that class. So any information that you put inside of that class, any variables, any methods, those cannot be accessed by anyone who is outside of that class. However, public, if you put those variables and those methods as public, anything can access those variables and those methods. If it's outside of that class, it doesn't matter. Anything can be accessed. This is why it is a very common practice, and I recommend you that you use this practice. in the future, we will make all of our variables, so all of our variables private. I have no idea what's going on with my mouse still. Anyways, all of our variables will be private and all of our methods will be public. And I will show you why that is important. But for now, just focus on the fact that you would not want anyone to come in and change your, for example, your house's roof color, right? Like if someone just came in and randomly just decided to paint your house's roof, instead of blue, paint it brown. Like we would be I would be pretty upset if someone just came in and did that to my house. So this is just a general idea. We do not want our variables to be easily accessed and easily changed by anything outside of our class. So variables private, methods public. This is an example of a class called cell phone. As you can see, they started with the capital C. So in this pseudocode, they're saying that class names has to start with the capital letter. Now, these are our field declarations, which are just variable declarations. So as you can see, we set them to private. The first one is a string called manufacturer. The second one is a string called model number. And the last one is a real number that's just going to store a retail price for us. Here are our methods. As you can see, our methods are public. Here, all of the methods. And each of these variables will have a setter and a getter. These are just another two definitions that you have to be familiar with, a setter and a getter. A setter is just going to allow us, whenever we want to set this manufacturer to some value. As you can see, we have not assigned any of the values yet to our variables, so these are just empty. However, whenever we want to set a value to our variables, we would do it with the help of a setter. So instead of directly going and directly changing our variable, we just have a method that's going to do it for us. And with this way, we make sure that it is very intentional. So whenever you want to set some value to a variable, it is very intentional. You have to actually call a method, and you have to make sure that this is exactly the right variable that you want to change. So each of these variables will have a setter, as you can see here, setter for model number, setter for manufacturer, and a setter for retail price. All of these. So, and each of these variables will also have a getter. And what a getter will do, instead of going into our program and just taking this variable and working with this variable, we will get the value. Only whatever value is assigned to our variable, this is what we're going to get from our class by using a getter. So as you can see, it's going to return this getter, get manufacturer, will return to you the value from manufacturer. It will not return to you the actual variable. So if you call this method, it's not going to return to you the actual variable. So there's no way that by calling this method, you will change the value, even by mistake. There is just not going to happen. This is the main reason for using setters and getters, to make sure that everything that you do inside of your class is intentional, and outside of your class, that everything that you do is intentional. If you want to get a value, you will get a value. If you want to set a value, you will set a value. But it's not going to happen by mistake. That's the only reason for using setters and getters. And this one, get manufacturer, will return to you the value from manufacturer. This one, get model number, will return to you the value for model number. And get retail price will just return to you the value that stores in the retail price. So for each of the variables that you create in your class, you have to create a setter and a getter. Yep, the fields, these are called the fields. The fields are created private just to ensure data hiding. So nothing can access those variables outside of the class. Nothing that we don't want to access, even by mistake, we do not want them to access those variables. Methods are public, so we can access our variables from our main class. And yeah, basically everything that I just told you. This is how you would call those methods. Let me show you. So this is our main module. As you can see here, this is class. This is a separate entity. This can even be a separate file. Okay, this can be a separate file as long as you store those two files, your main file and your class file, in the same folder. They can be different files. So let's pretend that this is a different file. This is not in the same file for code. And we are creating our first object. We are creating a cell phone object called my phone. So how you would create, this is pretty similar to every single programming language that allows you to use object-oriented programming. You would declare, and then you would put your class name, and then you would put the name of the object that you would want to create. In this case, it's my phone. Now, this would create this statement, the setter. This would make sure that my phone has all of the methods and all of the variables that your cell phone class provides. So by writing this line of code, set my phone equals new cell phone, we're creating an object from the blueprints. So as you can see here, all of these manufacturer, model number, retail price, set manufacturer, set model number, all of these methods are now assigned to my phone. So my phone has access to all of the variables and all of the methods. Now here we are setting manufacturer for my phone. We're setting manufacturer to Motorola. We're setting the model number to M1000, and we're setting the retail price to $199.99. So this is how you would set your values. Instead of just typing manufacturer, right before, how we would assign values to our method, to our variables before. We would just type manufacturer, right? We would use this word right here, manufacturer, then we would put an equal sign, and we would put whatever value we wanted to have. However, with objects, we do it a little bit different. We don't access the variable directly. We set it through a method, through our setter. So this is how you would do it. You would put the name of your object, you would put a period, then you would put the method that you would want to use, and then you would put the value that you would want your variable to have. In this case, it's Motorola. And this way, how you would get those values back from your object. So you can see here, we're just displaying the manufacturer is, and then we're using our getters. So again, you would use the name of your object, then you would put a period, and then you would put a method that you would want to use. In this case, it's get manufacturer, and this will just return to you what is stored in manufacturer. And what did we put in manufacturer? We put Motorola. So this line would print to you the manufacturer's Motorola. And the same thing will happen with the next two lines. We put M1000 into the model number. We're gonna get M1000 when we get that model number from our object called my phone. Same idea was 199.99. We're just gonna get that by using get retail price. Another thing called constructor. Constructor is a method. You don't have to initialize it. You don't have to do anything to create it. Constructor is whenever we did this right here, whenever we wrote this line right here, a constructor created all of those variables and all of those methods and assigned them to my phone. So what a constructor will do for you, it's just gonna create all of those object fields, and it's just gonna initialize those with the starting values. In our case, we did not have any starting values assigned to our values. You can see here, manufacturer will be an empty string, model number will be an empty string, retail price is going to be a 0, just because we didn't assign any values to our variables. You can write your own constructor if you want all of the objects to have the default values. So for example, let's go back to our example with the houses. If we had a class with the blueprint for a house, and if we wanted all of those houses to come in with a red roof, a brown, let's do red roof, red brick, and for example, a backyard. If we wanted all of our houses to come in specifically with the red roof, red brick, and a backyard, we would initialize those values using our constructor. But it's not always the case. You don't have to initialize your fields. Just if your program requires it, then you would build your own constructor. Okay, UML stands for Unified Modeling Language, and it's just a way to draw a diagram that's going to describe your object-oriented system, so your classes. And this is how the general layout looks like. So your class name would go in the first field, then any variables will go in the middle field, and any methods will go in the bottom field. And this is what it would look like. I know it's a lot, but let me just describe this to you. So as you can see here, cell phone is our name of the class, so it goes in the very top. Then these are our access specifiers. So a minus sign means private, means you can't access it, private. A plus sign equals public. So plus sign, everybody can see it, minus sign, private. And remember, our variables were private, so that's why there is a minus sign in front of the names of our variables. So there's a minus sign, you put your access specifier, then you put the name of your variable, and then you put what data type of that variable is. In this example, we have a private variable called manufacturer that is a string. Then we have a private variable model number that is a string. And we also have a private variable retail price that is a real number. These are all of our variables right here in the middle. Then this one is all of our methods. As you can see, all of our setters, all of our getters, and our constructor. This is our constructor. And as you can see here in this example, there's no constructor, right? You can't see a method called constructor. However, it's already, it's a default method. You don't have to write it. Your class already has it. Even if you don't specify it, your class will have it. And it will have a name of your class. Always, your constructor will be a method that has the same name as the name of your class. In this case, we have a public constructor called cell phone that sets manufacturer to a string, model number to a string, and the retail to a real. Then our next method is a public set manufacturer method that will set your manufacturer to a string. Same thing here. Public set model number sets model number to a string. Public sets retail price to a real. Now with the getters, it's a little bit different because we don't have to specify what we're setting our values to, right? Here we're specifying that we're setting retail to a real, model number to a string, manufacturer to a string. However, with getters, we don't set anything because we only get something. And this is how you would specify it in a UML language. You would put, again, your access. So in this case, is public. Then we would put the name, get manufacturer, parentheses, and then we would just specify which type of variable we return. We don't have to specify a name. We don't have to tell anything. We just have to specify the type, the data type that we are returning with our method. In this case, get manufacturer will return a string, get model number will return a string, and get retail price will return a real. All right, I know it was a lot. If you guys need me to go back and to another If you guys need me to go back to another slide, just let me know.
Mhm.
Let me stop